Welcome to the second half of today's C++ presentation. Earlier today we had a lightning overview of C++ for those new to it, and then showed upgrading some old C++ code to modern C++. Now we have something very exciting for you, a conversation between Patrick Scheller, moderator of the C++ Google Plus group and a developer and project manager, and Bruneau Babet, one of our compiler engineers. The topics are not so much specific C++ features, but rather C++ history, compiler internals, using and extending Clang, mixing C++ with other languages, and other things that will interest you if you're curious about compiler and IDE internals, or just getting a glimpse into the normally hidden world of compiler development. Thank you to Pat and Bruno for being here.
I'm a software developer and project manager, and I started to work in computers as a systems operator almost 30 years ago. Pretty long time. I've seen a lot, I've done a lot, and ended up with software engineering, which I really loved. And actually, C++ was my first love. So it was hard to enter because everybody said, oh, you should go for Microsoft Access or Visual Basic. And I said, no, I want C++. And I will find a job who will train me to C++. I got lucky, and here I am. Almost 15 years of C++, doing applications development mainly. But it's also a very interesting point, and I think that C++ still has a lot of potential here in this area.
Well, thanks for the introduction. Bruno.
I am Bruno Babet. I go back to Borland. I actually joined Borland in 1989, I believe. That was actually an interesting point. Borland was about to release version 3 of Turbo C, and they basically put a halt and released Turbo C++ instead. And in 1992, I joined the development team. I worked on Object Windows. And slowly, once you work on the runtime, you start working on the tools next. And from the tools, eventually I went to work on CBuilder, ActiveX initially, and SOAP later, and then more recently I've been working on the compiler. I worked on BCC32 for a while, and then with the switch to Clang, I worked with my colleagues here to implement what we refer to as the Borland extensions in Clang. And that's still what I do today.
Fantastic, thank you. So the Borland extensions are probably sort of unusual. I mean, even the fact that we use Clang on Windows is... So Pat, I think you were asking me about that earlier.
Yes, I think I have two questions for the beginning to Bruno. One is how did you came about deciding to use Clang? And otherwise also, since you're such a veteran at this company, how do you see the development of C++ from the compiler side over the last 20 years?
As far as the compiler development, I mean, it's changed drastically. It used to be a very, very niche market, and there were several compilers, a lot of them. And all with lots of proprietary extensions. And GCC used to be in a class of its own, meaning it was the only open source compiler out there. Over the years, we have looked at other options. Basically, the language evolved in such a way that our compiler, what we refer to as the classic compiler, could not keep up. It was just, I mean, there's lots of stories about that. Why? It's basically because we did lots of changes to a C compiler to accommodate C++, and it wasn't really built for C++. With the advent of, okay, I should go along the way, we tried EDG also, and we even released a beta product that was based on EDG, but that effort was cut short. And with the advent of Clang, I think things have changed so much. I mean, Clang has very, very much brought compilers, basically taken the mystique and what was very, very difficult before. Clang has made it very accessible. I mean, And so that was a decision. We had heard of Clang very early on, and we kept looking at it along the way. And there was one member of the team here, Barry, who had suggested that we even look at LLVM for code generation. Somewhere along the way, someone looked at Clang, I think it was version 2.9, and said, oh, this is looking like the time at which we would want to jump in. And I believe we went to one of the conferences. I don't remember which one. Maybe it was with the release of 3.0. And the team agreed that that was really the option that we should investigate. And that's, we went along and moved our extensions over there. I don't know if I answered all your questions, but the way I view the evolution, I have not always been a compiler person. I was mostly doing runtime, but the way I view the evolution is it's so much easier nowadays to do things that a compiler can do very well than it was, let's say, in the 90s. There were several efforts. There are PhD papers. There are lots of parsers around that you can find, and many fuzzy parsers and all kinds of heuristics that people do to try to parse languages, and some of them are very, very successful. I mean, Doxygen and things like that that need to just, let's say, look at the interface and generate documentation about code. You can do that fairly well, but to do things that a compiler can do requires really correctly parsing. Let's say doing something like code completion on a template, where you want to know which instantiation of the template really was there so that you can give the correct members when somebody is asking for code completion. That you really need a compiler. And I think Clang did a wonderful job in bringing compiler technology to the rest of the world. So.
Yeah, thank you very much. I thought you were freezing, that's why. I think, what did I want to ask?
There might have been something about, I mean, we have a bunch of compiler extensions. Like obviously we don't use stock Clang. And if you're curious about those, for example, Bruno, what are our compiler extensions and why do we have them? And does that sort of make the process of using Clang more difficult?
Oh yes, it does. I mean, the reason we have them has to go back to what CBuilder is as a product. And for that, you probably have to go back to the 90s, mid-90s. Borland had released Delphi, which was very successful. At the time, we referred to the framework strictly as VCL. Everything was VCL. Nowadays we've broken it up so that we distinguish the RTL from VCL proper, from XML, and from SOAP, and from database. But back then, everything was VCL. I mean, it's just that's the. You can see that even in version control. Still, we use the word VCL to mean the whole Delphi runtime, including RTL database. So there was an effort to do a C++ version of this successful product. It was actually codenamed Sci-Fi, which would be very similar to Delphi. That makes sense. But then the Delphi team came up with a alternate proposal, which was you could actually use Delphi and from C++, because the Delphi runtime could expose OBJs that C++ could consume. The prototype was written. It turned out to be yes. That's the way we want to go. That we could go to market faster. But there are lots of features of Delphi that do not have a direct equivalent in C++. And that's where the extensions come from. So I tend to refer to them as our Delphi extensions. Now, it doesn't mean that those extensions do not have value to plain C++ code. And they do. And some of those actually, it turns out that C++ as language evolved, meaning C++ 11, some of those features were embraced in C++, but and some were not. And there is also we did propose some of those features as extension to the language. They were rejected for very good reasons. So most of the extensions that we have to do with allowing C++ to interact with Delphi. So there will be things like properties and closures and events and some keywords that allow you to access RTTI, like underbound about class ID or underbound about Delphi RTTI. And a lot of decal specs, for example, those would be the way you can annotate declarations in a way that makes the compiler understand that those declarations need to be treated in a specific way. For example, the Delphi return decal spec. We put this on some classes to tell the compiler that those classes should not be treated as regular C++ classes. They are really classes that represent built-in types in the Delphi language. You might have seen them, let's say, on currency or on set or on dynamic array, and because these are built-in types of Delphi. So that's where the extensions come in.
I'm not exactly sure where is the connection between C++ and Delphi here, because even though I was an avid fan of Turbo Pascal and the GUI you had on the DOS, which was excellent, I must admit I didn't follow later on the Borland C++ builder line, and so I'm not exactly sure where is the connection between Delphi and C++ that you're talking about here.
The connection comes after Borland C++. So Borland C++ in itself was a standalone, fully C++ toolchain with runtime, object windows, and the compiler, and the editor, and the IDE, and so forth. The switch happened in the mid-90s, where after releasing the last version of Borland C++, we switched to C++ Builder. And C++ Builder was the same compiler as Borland C++, with some extensions. I'll skip those for now. But the IDE was the Delphi IDE, not the Borland C++ IDE. And the runtime was no longer object windows, but it was the VCL runtime. So that's where the switch happens there. I understand that the object windows library is still doing very well. It's available out there, and there's a team of people still working on it. But the product line of Borland C++ itself was stopped, and C++ Builder was born. So, and that's where the Delphi connection comes in, or Delphi, should I say.
Are you still using the runtime from Delphi now?
The runtime from Delphi, yes, exactly.
Oh,
the GUI runtime of C++ Builder is from Delphi.
Oh yeah, okay. But just for the C++ part, the pure C++ part.
Yeah, you can use pure C++ runtime and, you know, STL basically, and classic C++ runtime, standard IO, standard lib, and so forth. But if you want to use the framework, the BCL framework or the FMX framework, that framework is written in Delphi.
Does it make using both languages in a project easier because of that?
It makes it easier from a runtime point of view. You only have to write the runtime once. It makes it very easy for things like the debugger and all the other tools that come along. But I think from a compiler point of view, it makes it much harder, because we have to consume objects that were created by a different tool, and so therefore you have everything involved with whenever you have two languages to interrupt, which is the ABI has to match exactly, otherwise one side cannot interrupt with the other. And so hence those extensions. But even with those extensions, there are still features of the Delphi language which are not accessible to C++. Some of those because they are really deprecated features of Delphi. They're obsolete, I should say, not deprecated, but there are features where the Delphi team feels like, oh, we have a replacement, we have a better substitute nowadays. And therefore, for these features, they are not accessible from C++. Earlier, David and I were talking, the comp type came up, and that's a type that's not accessible from C++, and no one misses it. Or real would be another one. But I think it makes, to answer your question, it makes the runtime easier, but it makes tooling harder. So.
Was your question, Patrick, to do with, like, from a developer perspective, like using the two languages making developing apps easier, or was it about the
yeah,
runtime?
because it can happen, you know, very often in real life that you just have to develop something which was partly already written in one code by one team, and then the other team should just add something or make a connection. And then, yeah, the question is, will we rewrite everything, or can we just combine it somehow? And if there is some synergy for the developer, then that's great, right?
I think that's definitely a plus, actually. I mean, you and I actually were talking before this this chat session was recorded about using different languages for different purposes. Whether people sort of stick to a language that they know and do everything, or whether they pick and choose a language based on whether it's good or not. And I tend to find that having a choice of language but having them interoperate is a good thing. I mean, the VCL and FMX, for example, which are, I suppose, nowadays we just call them the UE frameworks, are written in Delphi, and Delphi is very good for writing that kind of thing. But C++ is really good for other stuff as well. It's very nice to be able to combine the two.
Yeah, I was being more provocative with this and saying that if you approach a new project, you want to make a new application, does it really matter which technology, which language you use? Does it matter? And if so, why?
I think it matters which technology you use in order to make sure that you can the technology can limit what other libraries you could use. So a good example would be, let's say there's a great .NET C# library out there that I may want to use, which my app, the language that I choose to write my app in may make it easy or hard for me to use that other library. But and also the tooling. I mean, there's a lot of tooling that rotates around a particular ecosystem or a particular language, and therefore the tooling that you use is greatly influenced by the language that you start with. That said, I totally value the ability to mix and match languages, and I wish that we could do a little bit more of that. That's not our focus right now. We tend to go more about embracing new frameworks and new platforms. I would say that the ability to mix and match is great. I mean, you can always mix and match. Even in the case of the C#, I think there are ways nowadays where you could create an unmanaged DLL and have it accessible and so forth. It's just that there's a little bit of overhead to doing that. So I think that sometimes it can be difficult if you're debugging, though, and crossing the language boundary can be a little difficult. Somebody who is very familiar with C++ might enter in some Delphi code that may not be very evident what it's doing, especially if it's using one of the newer versions of Delphi with some of the newer language features that you may not have been exposed to. But I mean, the runtime will take advantage of all the features, and therefore, if I end up stepping in Delphi code and I see some construct that I've never seen, I go down the hall and I ask some questions, and someone explains to me what it does. And
well, I do also have an opinion on that, naturally, and I got asked this question a lot of time during my career. When some projects started new, people were just saying, "Come on, let's do it in language X, Y, or Z. Doesn't matter, because what matters is the final product, and we know it, and this makes it less risky to use that language." But I don't always agree with that. There are so many factors in it that can make this decision go very wrong or very right. Like, for example, I saw big projects that were written by Java maybe 15 years ago, where Java was totally hyped and everybody wanted to do Java. And the bigger the project got, the lamer, slower this project became, and the output, even though the project was not finished yet, the output was so slow, the performance was so deadly slow, and they were absolutely running behind those parts of the code where they could probably squeeze a little bit more performance out. But it was clear they would never bring out a project, an application that was running smoothly. It's a classical thing, naturally. Every C++ developer will sit back and say, "Yeah, I told you so, C++ is faster," naturally. But then also comes in the complexity and the problems that you get during the development, which is also not neglectable. Like, how much time will it take to develop that application? I mean, if it's going to take 1 year longer, that's going to cost, I don't know, maybe 5 million euros more. Can we afford that? Do we want to afford that? That's a good question too, right? And then also, the quality at the end of the result, the application itself. itself. I mean, do we get better quality of an application when we've written it in C++? Or would it be better with another language? And there, you said it right, the tooling comes in, which is today, I think, easier and better and more comfortable than ever, with a lot of tools helping us to improve our code. It's not just lint on a DOS level, and that's it. We have, as you said, Doxygen, we have debuggers, we have unit tests, we have CI, and everything else that helps us improve our own code and the quality at the end.
I think one of the things that surprises me, actually, on the topic of using C++ or picking languages or that kind of thing, is that C++ isn't used as much on mobile as I would actually expect. Mobile phones are sort of quite resource constrained in a way. They can be CPU constrained and memory constrained, and sometimes the languages you use on Android, for example, the memory behavior can be a little odd, especially for a device that has constraints. Whereas a language like C++ is, you can control that, and it's very predictable and probably a lot more efficient.
But it does have a C++ interface. And if you want, even on an iPhone, you can use C++ via, for example, Qt, the Qt library.
Well, this is where I have to mention that you can use C++ with our frameworks as well. I mean, yes. That's one of our big things. We compile natively to iOS and to Android.
Oh, you mean with C++ Builder?
Yes, yes.
Oh, that's excellent, yeah. That's great, yeah. So that's a big help, because otherwise, I mean, you have to rely on really archaic and poorly documented SDKs from the developers of the operating systems on that level for C++. I mean, like Apple, they have probably an outstanding development documentation for Swift, but go look for C++.
Bruno, you can probably chime in here. I mean, you've actually implemented the compilers for iOS and for Android, and we're working on Linux right now as well. That's what Bruno's working on today, I imagine.
Oh yeah, that's what I'm working is moving our extensions to Linux. I suppose I think that there's always C++ is a very powerful language, and at the same time, it's not necessarily the language where you get the most productivity. I know some people might disagree with me, but when it comes to especially those devices, let's say on Android, yes, you can use the NDK and write some very low-level engine code, but you still need your GUI and you still need to interact with several libraries, and so we do that, but not everything actually goes through the NDK. Some of those things may have some bridging that actually then talks to the actual Android API itself. There are several libraries that are off limits, so it's a matter of productivity at the end of the day, I think. As much as I love C++, I don't see it as the optimal language in all situations, and I know that some people disagree with that approach and or that viewpoint. And but since we brought up iOS and Android, those are classic platforms where you want some C++, but you don't want only C++.
Yeah, I think I agree with that. And mainly not because C++ couldn't be used, but mainly because it's just more convenient to use the native platforms. Tools and language parts. That is true, yeah. And evidently, in the end, an application has to be finished in time, not to be too expensive. But you mentioned the cross-language barriers, like with Java, with Delphi, with other languages. This is very popular today. You have language libraries like Swig, for example, which offer this part where you can use C++ to develop extensions for a whole slew of other languages, which is great. Some languages also offer a C, at least, interface which you can use. So I think this is still used in many parts, like, for example, PHP. A lot of extensions are written in C or C++ because of performance, right?
I am not very familiar with interfacing with PHP, and but I understand the concept. I have interfaced with some Python. The one that I'm very familiar is interfacing with Delphi, of course. But at the end of the day, it's always the same issue. It's understanding ABIs, and because at the high level you can access an API, but what I deal with are things that happen behind the scene. Will this side push the parameter using the right register? Will the other side receive it in the same way? Will they clean the stack properly? Will they understand? I mean, it's basically calling conventions and ABIs, and so each platform has different ABIs and different calling conventions. And when I'm interacting with Delphi, that's even more relevant because both compilers are developed in-house. The person who does the Delphi compiler and the person who does the C++ compiler are both here. And therefore, we have to understand each other about how we're going to handle, especially Delphi types. Types that are prevalent on the OS. Let's say we are on Linux, for example, or on iOS or on OS X. The OS defines a set of core types and defines the ABI for those. But then Delphi brings in some new types, some new data types that are not represented on these OS. Delphi will bring in strings or currency or sets, and there that's the bulk of not the bulk, but a lot of what I have to do is to make sure that C++ can interact or interrupt with Delphi code at that level. But I have studied Swig to better understand how it generates bindings. We had to do something similar for iOS not too long ago, several revisions back, but not too long ago in terms of, I don't know, 2 or 3 years. We were looking at the bridge. Apple had an iOS bridge at the time, and we were looking at how we would interact with the iOS runtime from Delphi. And so it's solving the same kind of problem, whether you use a separate tool to generate a binding, whether you built it into the language. Some languages have built extensions in the compiler itself, that the compiler understands, that allows you to interact with another language, or whether you use some intermediate library. They are just different solutions to the same problem, which is interoperability between languages. So it's an area that I enjoy working with a lot. Because it solves a problem that the end user doesn't have to think about that. At the end of the day, you want the end user to say, there's this library here, and there's my code here, and I want to be able to use them. And building the glue between the two to make this seamless is one of the pleasures of my job. So.
Yeah, I think that is what professional commercial IDEs and compiler vendors should offer. I mean, but convenience and time-saving features are what we are seeking for, naturally. This is why some people then think, okay, C++ Builder has this or that feature which makes my work much easier. I'll choose that one. But can I ask something? I heard from David that you were working very early on with Clang already, when probably no one else was really using Clang, and you also used it on Windows, right?
Yes.
Many years ago, when Clang itself was not ready to be used on the Windows.
Yeah, Clang
but it still is just limited today, right?
Yes. That was I mean, Windows is the main platform where our tool runs. We may target other platforms, but we run on Windows. We looked at Clang in version 3.0, and there were no Windows version of Clang at that point. But we were also very aware of the problem that we were trying to solve, which is replace our compiler. The compiler is just one part of the big tool chain. You need to answer lots of questions, which is what's the object format that you're going to use, what's the debug format that you're going to use, and then what linker will you use, where will you get your library. It's always fun to say, okay, I can just build hello world. You know, you type your little hello world, you run the compiler, and out comes out an executable that you can run. But there is
and
a
you have to
lot,
interact with the OS, right?
yeah, there's a lot that
which is a big part.
yeah, and there is a lot that goes on between compiling the little code, the hello world, to generating an application that can run, and even more, an application that can be debugged. So you need to be able to step into a debugger and step over your line. Oh yeah, here's hello world, and we step, and here comes the output. And so we did have our own toolchain to begin with. We had our own linker, we had the object format that we were using, we had our librarian, we had our debugger. So it made it very clear about what we were targeting, what part Clang would come in and play for us. And we probably spent most of our time working on the object output, the format, and exception handling also. Exception handling is very key, and that usually goes very, very low level to different, well, depending on the platform you're in, whether it's on Win64 where the OS provides supports as long as your toolchain produces pdata that describes to the OS exactly how to unwind, or on Win32 where it's a little bit more, there's more bookkeeping. The code itself is very well aware of the frame we just entered, what objects has been created, what needs to be destroyed, and there's what we refer to as the FS chain that needs to be kept active. So then there's more code generation. So the first platform we targeted was BCC64, was for Win64, because it made exception handling actually a little easier, because we would just generate pdata and then the OS would take care of the rest. The tooling, the librarian, and the linker were things that we had been working on anyway. And so, but they were still, there was still work required there. So when we say that we had Clang on Windows, that's one small part. It's not small. I don't want to belittle it. It is significant, but at the end of the day, what you get is you get some object files. And whether the object files has enough debug information that your debugger can run with, whether you have a linker that can link that, and whether you have a runtime that can come and complement the object file to produce an executable that can run on that OS, those are additional steps that we had to take. And recently we made the compiler available by posting an updated version of the free tool that we had been making available. And that's a Clang-based free tool. But along with that, one can see, if you download it, then you can see that, oh, there's a runtime that goes along, and there's a linker, and oh, there's a librarian. So to answer your question, Clang was amazing. It was a pleasure to work with as soon as we started, and I think even though we were not planning to release the Clang compiler for at least 2 revisions, we had one product coming up, and I made a proposal that we release audits, some auditing pieces built on Clang. And then the next release is when we then put out a Win64 compiler that was based on Clang. So
back then that was Clang 3.1, I think. And we've upgraded Clang since, and we're now planning to upgrade again to 3.9. Now with some of the properties, for example, that might cause issues. I know, for example, that we have property extension, for example. Microsoft has a property extension, which I believe is in Clang. What kind of issues would that cause?
Well, what's going to happen, I think, when in the next version, is we have added lots of extensions to Clang, which are now part of core Clang. They are in core Clang with a different implementation in mind. In this case of the property you're referring to is the DeclSpec property, which is one of the Microsoft extensions. Our property is actually with a keyword, underboundable property, where that's just the way we implemented it. Behind the scene, the two are very compatible, but not totally identical. The implementations are very different. The Microsoft property model differs from ours. Like, I can give one example. Like in our model, a public property can be backed by a private data or private member. Not in the Microsoft model. So, but at the same time, the current Clang supports the Microsoft model. So what we want to do, we don't want to bring our property implementation to the latest version of Clang, what we are doing is we are basically just reworking our implementation to reuse what's there already and then make additions where we need additions made. Because that's the better way of embracing Clang, is to use Clang as features get added to Clang, is to embrace them, as opposed, and if there's code that's in the Clang compiler that can meet our needs, that's where we want to go. And then we don't want to maintain two parallel implementations. But there are differences. Properties are just one of the ones you mentioned there. Even the way we do DLL import and DLL export, which is a more classic, I mean, anybody who's done Windows programming is familiar with that. There are little subtleties in the Borland implementation of DLL import, DLL export, and the Microsoft implementation of DLL import, DLL export. The same can be said about select any, for example. The way we, just the subtleties, like what do we allow you to do with select any? We require that as you're declaring the select any, you initialize it, and the Microsoft version does not require that. It's just little subtleties, but they do show up at the implementation level. So you will get a warning or an error, and so therefore we have to make little amendments where because we want to keep supporting the code that we compiled with the classic compiler.
I find it very interesting that you say that you want to go as standard as possible with Clang, and this is a very interesting approach.
I think what I've been pushing for is moving away from our extensions and embracing the standard wherever possible. A good example of that would be enumerations. In Delphi, there's always been the ability to make what they call scope enumerations. And there's a $ scope enum directive, and C++ did not have an equivalent for that, so it caused conflicts, because a Delphi runtime developer could write code that would cause problems to C++ users, and those were the problems that were very subtle, because you wouldn't find the problem when the code was converted to C++. You'd find the problem when you refer to the enumeration. You refer to a member of the enumeration, and at that point you find out that it's ambiguous, because at the time we didn't have scope enumeration. Now C++11 does support scope enumeration.
Exactly.
So that would be an area where we say, okay, let's embrace the standard. Let's not.
So you were actually ahead of the time, right?
Yeah, and there are other areas like that. The Delphi, method reference, and C++ Lambda would be another good example of that. When Delphi first supported method reference, we exposed it in C++ as an interface with an invoke method, and so you are on your own as to how you would interact with the Delphi API that expected a method reference. And then with C++11 comes lambdas. Okay. Lambda is a perfect fit for this feature, and therefore we want to embrace the standard. So the way we want users to see a Delphi method reference is as a lambda in C++. And so things like that, if we move towards that, those ideals, I think what happened, it will diminish the number of extensions that we need to add to the language. It won't eliminate them totally. And Patrick, as far as your point about making suggestions for some of those extensions to the language itself, I am not very positive there, because, well, there are two reasons. One is some of those extensions were proposed back in the old days. You'll have to go back to early C++ meetings. At least there was one, I think, even if I'm not mistaken, it was probably held in Santa Cruz, not too far from here, or shortly before or after the Santa Cruz meeting. So that would have been at the end of the 90s and the beginning of the 2000s. And also, I do not believe that some of those extensions would provide any value to C++. So when the extensions are there for interoperability with Delphi, that's what they are for. I mean, there are lots of other well-known examples of other C++ compilers having extensions that are there strictly to interop with other languages. And so those extensions don't really belong in the C++ language itself.
I understand. I wasn't only saying it's all about extensions. I mean, just in general, you're having C++ Builder, a complete product using Clang, and naturally there could come up some ideas where you say this would be nice in C++.
Yeah, I agree, and I think there are some things that some of the extensions that we've done that were targeting Delphi that could be of value to someone outside of the context of Delphi. I mean, it's something we see a lot. We see a lot of C++ code that's strictly C++. I mean, they're not interacting with Delphi, they're not interacting with DCL or FMX, and yet they use properties. I mean, it is a useful feature. Whether someone agrees with that as something you should do, or whether someone says, no, you should write standard code, that's debatable. But we do see quite a few customers of ours who will use the extensions outside of the context of Delphi interaction.
I would like to go maybe out of the down to the metal part of the compiler and just stand back and let me say, or let have you say, what makes a good compiler, in your view? We have so many nowadays. I mean, it's amazing.
Well, we do have many, but at the same time also, I mean, I've seen it dwindle. I think there are many Wizard C, Digital, Watcom. I mean, I could, back in the days, there were so many other compilers. Yeah. I think what makes a good compiler nowadays is one that can keep up with the standard. That's and Clang and GCC and Visual Studio also are great examples of that. I mean, you can see that that's key nowadays. And EDG, I should let out EDG. But also performance. I mean, the users are very. I mean, everybody is aware of the fact that if your compiler runs fast, you're more productive. I mean, if you have to go get tea while you wait for the build, that's fine. But if you have to go to lunch, then that's worse. I mean, it's just, you can see the progression there. But I am also more interested in the compiler from a point of tooling productivity. I don't know whether that's the right word, but I'll refer to it as productivity features, or IDE productivity. To me, I don't want my code completion, or I don't want my refactoring engine, and I don't want my documentation tool to be another parser. I want the same compiler that compiles my code to be the one that generates my documentation, that does my code completion, and that helps me do refactoring, let's say. I'm just picking a few things that are part of what we consider productivity features. And
you're saying that because many are using Clang as an IDE helper, actually, to parse C++ code, right?
I think, I mean, Clang
like
is...
CodeLine, for example.
Oh, yeah, and Clang has a library, libclang, that's totally focused on that that aspect of programming, which is not just I need to compile your code, but I need to provide tooling. And I think the tooling, and C++ has a long way to go as far as tooling is concerned, especially if you spend some time doing, let's say, C# or, I mean, other languages. And I think that a compiler that provides tooling ability is a great compiler. And I guess I'm singing the praises of Clang there, but I see it as more than just a great compiler. I see it as a compiler that has the ability to enable tooling for C++ at a level that we haven't seen yet. So, to me, that's a great compiler. You said to step away from the metal and the code, but I'm somebody who writes code against the compiler, so I will open the cover and look underneath. And a great compiler is one that you can easily extend. I mean, you can easily customize, you can easily extend, you can easily understand.
I have to say, there is something that I do dislike about Turbo C++.
Yeah.
I have to admit. You know what?
No,
it's still used in universities today, and taught today to new students. Like, for example, in the regions in Asia, like Pakistan and India, those poor students do have to learn Turbo C++ on the DOS still, because it's free, because it's available. So that's a downside. I mean, it's so popular now, and you're a victim of it.
I mean, we've talked about initiatives to make sure that people move, and we've made an updated version of the compiler available that supports C++ 11 runtime. I think ultimately it's partly us. We, as a company, we have to make it a value proposition that it will be easy and there's value, but also I imagine that people who are studying under Turbo C, I think they should understand that they're not setting themselves up to be in the best position to join the workforce, or whether it's a hobby or a professional position that they want later. I don't know. I mean, it's great to learn. I think it's great. I would encourage anybody to learn, and if you're learning with Turbo C++, but definitely I would encourage students to reach out and make it known to their professors or to their the university, the institution, that they want to use the most up-to-date tools, and they want to be, stay up-to-date with technology at least. David, I mean, I don't know if you have other ideas.
No, I think that was a good answer. I mean, one of the reasons that we actually released an updated free compiler recently was because so many people use the very old free compiler from that's what, 15 years old or something. The C++ it supported was 15 years old. And so the new free one is hopefully effectively a drop-in replacement. I mean, it is the new Clang-based compiler, but even the command line options, for example, are compatible with the old version. And so we are hoping that people will find that easier to use when they were using the old compiler and the old technology. They can sort of move to a new Clang-based, the new language, the new features, and that kind of thing easily. Supporting students and learning and stuff like that is a good thing to do as well. And so it's nice to kind of upgrade to a newer version and give them that.
It's not nice, David. It's vital. In my communities, we do have a lot of those students posting C++ code from the 90s today. David, why don't you let us give some insight into the roadmap of C++ Builder?
Sure. Well, we actually just released a roadmap a couple of days ago. I don't know if you're asking the question because you saw that or if it's pure coincidence, but we did. Actually, before I answer that, like on the topic of picking things that we support and picking features, there are a lot of ideas and a lot of things that you can do, and like choosing that is sort of a combination of where we already are and what our users do, and what we think will be useful for them in future as well. So the route that we're sort of going at the moment is practical use. When you get down to it, the tool has to be very useful for a lot of people, and so that's one reason why we've been focusing on cross-platform a lot, for example, because people it's very useful for people to be able to take their code and use it on other platforms, write an iOS and Android app and not have to worry about redoing the UI in two different layers and two different tools and that kind of thing. And so choosing something like that, I think ultimately comes down to what is the most valuable, what in practical use day to day when you're actually writing code, when you're dealing with an app, what's the most valuable thing. But the reason I mention that is because putting my PM hat on here, we are always interested, and speaking to the people who are going to be listening to this chat, we are always interested in feedback. So I want to invite you to give feedback in what's useful and what you want to do. Well, I think one of the main things is that, I mean, as you know, we use Clang-based compilers, and so we're not lagging, we're not quite up to the current version of Clang at the moment. Our compilers are currently based on Clang 3.3. We've backported a bunch of fixes and that kind of thing. But what we really want to do is to be up to date with the current version of Clang. And so we have all our platforms, all using the latest version of Clang with our extensions, and all sort of moving forward at the current pace. So that's the big roadmap item actually is to do that. And there are other things as well, like adding we're sort of releasing Linux, I don't know, soon in a few months, I suppose, and things like that as well. But that's the biggest roadmap item. The other items on it are things that sort of probably more interesting for people who already use our tools, features they've asked for and things like that.
And if we can maybe talk about C++ a little bit, since you said you will update to the new version of Clang, this will also mean you'll have a higher compatibility with the newer versions of the standard.
Yes, and that's a big goal, of course. I mean,
yeah. As of now, you have C++ support, C++11 support, right?
That's right. Yeah. And obviously we want to support newer C++ than that. C++ 11 was the big one. That's the useful, important one to support, I think.
This was a game changer. C++ 11.
Oh yeah, definitely. I mean, it was. It had been a long time. It had been 5 years or 10 years, depending on how you want to look at it. Even more. From '98 to 2003, it was for us, especially for the interrupt that we do with Delphi. It was very interesting as we were looking at the various features being added and how they would jive with the framework and the runtime and the tooling that we do. So.
Yeah, I'd say even it was a vital shot to the community as such. Suddenly people were enthusiastic about C++ again. It was incredible. I can say from the community that was really boosting. We have two communities, one with over 100,000 and one with 40,000 members. I mean, that was unthinkable before 2011. What is, in your view, I mean, both of you, what is your favorite feature of C++ 11?
Bruno, I'll leave that to you.
Well, I think I love lambdas. I just love just the flexibility that they offer. Everything that I've always wanted to do with it. Just, I mean, if you spent your life writing a bunch of callbacks, and you have to work in a compiler actually to see some of that. I mean, there's lots and lots and lots of callbacks. I mean, the ability to use STL and combine that with Lambda and is clearly my favorite feature. I mean, some of my colleagues may say things like R-value reference. For example, if I were to pick one item, I would pick Lambda.
I think I would go for type inference. To me, one thing I particularly sort of dislike in code is duplication, and also having to do something yourself that a computer can do very well for you. So like a really simple example is you write type foo equals, I don't know, new type or something like that. You immediately have the type twice. Why? I think I have to be careful here that the code has to be clear. To me, the really appealing reason is avoiding programmer doing work that a compiler can do for you. And I like a language that does things like that.
Yeah, I see what you mean. And I must say that I do like auto, but on the other hand, I always have this reservation that I think you should know what the type is that auto will return. Because if you start to ignore what types you're using, we're going into Visual Basic, area where developers will just not know what they're doing, and they're just using auto because they say, okay, let the compiler do this. Something good will come out of it, and that's not always the case, right?
I think that's true. Yeah, like any language feature, you have to be, you have to choose when you use it. I mean, I think your code needs to be clear and understandable and easy for you to know what you're actually dealing with. I'll probably draw this to a close. So thank you very much, both of you, for attending.
Thank you too, also for the very interesting talk and giving the chance for the community to have a look inside the compiler and the features that C++ offers.
So also as part of the cooperation with the C++ Google+ community, we have a promotion as well where you can get 20% off the upgrade price. So we have Starter that's free right now for these webinar sessions, but 20% off the price of an upgrade from that to our professional or enterprise as well. And so thank you, Pat, for organizing that.
Thank you.